Hello everybody, this is Holden and I'm back for the first exam review. First I'll go over the format of my presentation. I'll first go over study device, then go into content review. So in regard to study device, I suggest that you first review content. That means going through the homeworks and lectures, making sure you understand both all the R functions used and all the conceptual knowledge you need to understand for the test. Next, take the practice exam when you're ready. The TAs are holding a review session Monday to go over the practice exam. Take it before then and emulate testing conditions, which means time yourself and only use your exam sheet that you prepared during content review. And then review all questions on the practice exam, even the ones you got right. You want to make sure you truly understand everything conceptually. Now into content review. I divided the content review into three categories: data, types of plots, and randomness and probability. So the first section is data. The first type of data you need to know is cross-sectional. It's collected at one point in time across a range of observational units. An example is scanning a sample for a disease at a certain point in time. Time series data is taken at successive time points, and it's like stock price measured over time. Quantitative data is numerical values for which you would use arithmetic functions, such as height and weight. Categorical includes categories into which things fall. So an important thing to understand is that while all of these are examples, zip code and phone number are numbers. So it's very important to understand why we use them for categorical instead of quantitative. The reason why is you wouldn't do anything arithmetic with zip code or phone number. For example, you wouldn't take the mean zip code or the mean phone number. That wouldn't mean anything. However, if we sorted the review session by zip code, we could figure out who lived in certain areas. But if we just averaged it and found the range, that would be essentially meaningless. Same with phone number. There are two measures of center you should know, mean and median. They're used for different purposes. If you have a lot of outliers, you should use the median because they affect the mean more. So when it's skewed, you use the median. How you would do this in R are the mean and median functions. Next, you need to understand spread and variability. There are a few measures of spread you should know: range, quartiles, and IQR, variance, and standard deviation. Range is sensitive to outliers, and it's not very descriptive. Quartiles and IQR are affected less by outliers than range. Variance that's another measure of spread. It has squared units though, so we use standard deviation often instead, which is the square root of variance, so the units are consistent. Here's how you would find these things: the summary function and the SD function. One of the questions someone had was, how is summary different from 5num? To find that, you use question mark and then type in 5num. Remember to have a question mark in any function you use, and it will tell you what the function does. Same with summary, except summary is a bit more self-explanatory because it prints what each value is. Next, I'll talk about outliers. They affect every statistical method, and you always need to take them into consideration. We can mitigate their effects by looking at the median instead of mean when looking at center, but they do really affect every aspect of the data somehow, so always take them into consideration. A z-score shows how many standard deviations above or below the mean an observation is. Positive is above the mean, and negative is below the mean. The absolute value is distance. So for example, a z-score of 2.75 is further from the mean. The difference between positive and negative is 2.75 is above the mean, 2.5 is below the mean. So that means 2.75 as a z-score is more rare. To do this, you take value minus mean divided by standard deviation. It's important to know to use parentheses here, because if you don't include the parentheses around value and mean, R will divide the mean by standard deviation first, but you want to make sure it's computed in the correct order. Next, I'll go over types of plots. First, you have a few quantitative plots, including histogram. You use hist and then your data frame, and x, whatever your x value is titled. This is an example of a symmetric histogram. This is a right-skewed histogram. This is a left-skewed histogram. Here is a unimodal histogram and bimodal histogram. Next up is box plot. Central box shows middle half of the data. The median is centered. Well, if it is, it means the middle half is symmetric. and the whiskers show skewness if they're not the same. I have also attached the R command and a picture of a sample box plot. Here is stem and leaf. Now, something really important to remember is the area principle. The area principle basically means that when you have scaling, you need to include the area has to be proportionate to what you're trying to represent. So B looks like it's 9 times bigger than A because the way they drew it, it is 9 times bigger when really they're saying, as far as we can tell on the y-axis, that it's only 3 times as big. So a normal graph would show that. This graph is a violation of the area principle, and the rightmost graph explains why. Next, let's go over categorical plots. This is a pie chart. I took this out from my command for the homework. One of the homeworks instructs you to create a pie chart. This is the command to make a table. Next, we have a three-way table. So we're taking smokers' outcome and we're dividing it by age. So as you can see, we get 2 different tables, one for each age division. Next up is a prop table. So there are 2 ways to do a prop table. You can either do prop table, table, and then create your normal table, or you can make an arbitrary table name, meaning you can name it anything, your table, and then do a prop table of your table name. I prefer the second way, the way around which I'm circling my mouse, because there are there's a lower room for error because you don't need to keep track of as many parentheses or anything of that sort. So here's a prop table down here. I have an important note regarding prop tables. So if you make your prop table and you don't have any comma and a number, 1 or 2, then every number will sum to 1. If you have 1, the rows will sum to 1, and if you have a 2, the columns sum to 1, the probabilities. So you use all of these to answer very different questions. Again, I have the same exact data on all of these, but I'm changing the margins, whether the rows add to 1 or the columns add to 1. And these would all help you answer very different questions. So in the review session, someone asked, what scenario would you use for each? So I'll go over those. On the one where you don't have 1 or 2 and it all sums to 1, I could ask a question such as, out of the people sampled, what percentage did not smoke and are alive? That would be 38%. With 1 where the rows add to 1, I could ask, of the people that are alive, how many smoked? And the answer would be about 47%. I could also ask, out of the people who are dead, anything regarding alive or dead because they're the X that's being summed to 1. Next up, I have 2, which means the columns sum to 1. So an example question for this scenario would be, out of the people that do not smoke, how many are alive? And the answer is about 69%. Out of the people that smoke, how many are alive? About 76%. Okay, now let's do bar plots. To create a bar plot, first you create a table, you name the table, you create a prop table from the table, you name the prop table, and then you create a bar plot for the prop table. So again, I've shown the 2 methods. The first, you have bar plot, prop table, and then your table name. In the second, you're naming your prop table and you're doing a bar plot for whatever you named the prop table. Again, I prefer the latter because I feel that there's less room for error because you are naming each individually, so you don't need to be concerned about parentheses, and also you can choose whether you want to sum it to 1 or 2 and not have to worry that you're putting that in the wrong place. So my bar plots. Again, the 1 and 2 literally affects everything about the prop table, and it will make your bar plots or mosaic plots work different depending on what you do. So a mosaic plot, you have the same preparation as the bar plot in regard to making a table than a prop table. The difference is you're using mosaic plot command instead of bar plot. Section 3, randomness and probability. My best advice for this section is to go to the back of the book and work as many sample problems as you can because you're going to run into lots of different scenarios some of which are hard to understand conceptually. So I think it would be good to get as much practice as possible. Here's a contingency table. Shows a relationship between two variables, one category in rows, one in columns. So what you find in the middle that's highlighted are joint probabilities. On the outskirts of the table, we find marginal probabilities. Both are intuitive because of their name. So for independence, independence is when the distribution of one variable is the same for all categories. So in the particular example I used, it would be if the same proportion of males and females were right-handed. That would mean handedness, left or right, would be independent of gender. Again, it's the proportions, not the numbers. I've also typed that under example, so you can pause the video and think about that if you would like. Association are when there are two different conditional distributions. So going back to the table, they'd be associated if, for example, a higher percentage of males than females were right-handed. Then we would say being right-handed is associated with being male. So it's very different from being independent. If it's not independent, it is associated in some way. One thing that people get caught up on is randomness. The outcome of one coin flip is unpredictable. I understand we use this example a lot, but it's the best way to understand. So each coin flip is unpredictable. We know it's a 50-50 chance, but the outcome is unpredictable, but there is a long run pattern. So when something is random, as I mentioned, we cannot predict individual outcomes. This segues into the law of large numbers, which means the probabilities even out if they're the same probability given enough time. So if we have 1,000 coin flips, there will be about the same number of heads and tails, and with 10,000 coin flips, it will be even more even. So a lot of people have a misconception about the law of large numbers, and that leads into the pseudo law of averages. It arises from people's misconception that the law of large numbers applies to individual circumstances. So for example, if I flip 10 heads, what is the probability of flipping a tails? It's still 50%. Some people would say you're more likely given that you flipped more heads. Another way of putting this is that it depends on how you phrase the question. If someone is asking what the chance of heads is, it's always 10%. If they ask what's the probability of getting 10 heads and a tail, then you have to do a different calculation. But if it's purely you've already flipped X heads, what's the chance of another one? It'd be 50%. Because the past coin flips do not predict the future ones. So, general probability rules. The total probability must equal 1. All probabilities must between 0 and 1. You have the complement rule, which means if there are only two events, A and B, 1 minus A equals the probability of B since they all sum to 1. For example, if A is 0.3, the probability of B is 0.7. Those are the only two events. 1 minus 0.3 is 0.7. So if they're independent and you want both to happen, you would do probability of A times the probability of B. And if they're completely independent, when you're doing the general addition rule, you need to add the probability of A and the probability of B, and then subtract the probability of. So it's very important. On this slide, I have the probability or written this way, but when it's general addition, you need to account for the area in the middle. When it's disjoint, you can just simply add them without subtraction because there isn't overlap. But in this circumstance, when they're independent, add the probability of A, add the probability of B, and then subtract the area of both. So as you can see, this mathematically, we're solving for the area of both and just making sure we don't double count the center. Disjoint are mutually exclusive events that cannot happen. Knowing one tells you the other because if it's A, then you know it's not B. If it's B, you know it's not A because they don't overlap at all, whereas we can't learn the same thing from independent. Getting these definitions straight is very important. So here are probability trees. Someone mentioned that you do not need to know these for the exam, but in regard to probability, it is important to know how to draw them out. you probably won't be given one, but it's important to understand what it means so you can solve other probability questions. Objective versus subjective probabilities. I have this written out completely on the slide. It just depends whether you can estimate it from data or not, and I have some examples. For the subjective example, what is the likelihood of making your parents proud? You really can't predict that from data. So it's subjective. It depends on your judgments and opinions. A sample space is a set of all possible outcomes. That's just a discrete question. Here are some examples that are important. I made these up based off of one of the tables from Dr. Greenberg's PowerPoint, and I just made some questions off of it. So you should be able to answer all these. So I'd encourage you to pause the video now, take a stab at all of them, and then unpause in a few minutes or however long it takes you to solve them and look at the answers. So what is the likelihood of choosing a woman at random? So all the probabilities sum to 1. We have 0.3 plus 0.3, so that sums to 0.6 women. What is the likelihood of choosing a woman who uses a credit card at random? So this would be a joint probability. We're looking at credit cards and women, so it's 0.3. Given that someone uses a credit card, what is the likelihood that the person is a woman? So since we're given that signifies that something will be the denominator. So given that someone uses a credit card, that means the denominator will be 0.55. And what is the likelihood that the person is a woman? So 0.3 over 0.55. Given that the person is a woman, so again, given that signifies the denominator, so we know the denominator is 0.6. What is the likelihood that she uses a credit card? So 0.3 over 0.6, which that once you actually divide those, it's 0.5, and we can see that it's about 50% because 50% of the women use credit cards and 50% do not. And the last question, what is the likelihood that someone uses a credit card? We can sum these. It would be 0.55 in the margin. And we went over the Q&A session. I shared with you some of the most valuable questions that people asked. But really, from this point, you should try to become more confident and get ready and take the practice test. As always, let me know if you have any questions. I'm holding my emails on all of the syllabi. Feel free to shoot me or any of the TAs a question or come to office hours on Monday. Good luck.